Hello everyone, welcome to ZNZ Classroom. I'm Mary, and in this video, I'll be discussing with you about how to graph absolute value functions. Before getting deep into the graphing part, let's first look at the definition of absolute value. Here is a modified definition of absolute value that I think is simpler to understand. So it basically represents the distance between 0 and a certain value. So I underline distance here because it's pretty important to know that absolute value is non-negative. It's positive or 0. So distance, you could never travel a negative distance. It could be 0, it could be positive, but it could never be negative. So absolute value is non-negative. Now let's look at the parent function here and plug in some x values. So what you have here, this symbol represents absolute value. And if I plug in my x here, that means the absolute value of that number. So let's first plug in -3. If I plug in -3, what is the absolute value of -3? So if I draw out a number line here, maybe it's better for you to understand. -3, -2, -1, 0. So based on definition, it basically means the distance between -3 and 0. So what is the distance? 1, 1, 2, 3, right? The distance is 3. How about -2? I have 1, 2. The distance is 2. And if it's -1, I have 1. If 0, it's just 0. So that's just for the negative numbers. And for the positive numbers, it's actually pretty easy because if it's 1, the distance is just 1. If it's 2, the distance is 2. If it's 3, the distance is 3. So sometimes you basically just ignore the sign, and usually people also call it magnitude, which basically is the absolute value function, the absolute value of that number. And now let's plot those points. So let's plot these points over here. Okay, so now we can connect those points and get an absolute value function. So if you notice here, it's actually symmetric about the y-axis. So it's actually symmetric about this line over here. Let's see if I can do that. Okay. So it's actually symmetric about the y-axis. And let's do some analysis. What will be the domain of this function? So the domain of this function, it goes all the way to infinity to the left and it goes to infinity to the right. So my domain is -infinity to infinity. And for my range, it actually does not go to infinity downward because there's this minimum point here. So there is a minimum over here. This is a minimum y value, which limits our range to 0, comma. It did go infinity upward, so 0 to infinity. And then for end behavior, we have x approaches -infinity and f of x approaches. When it goes to left all the way, I goes up all the way, so approaches infinity. When x approaches infinity, f of x still approaches infinity because when I go right all the way, the graph also goes up all the way. So then we have the vertex. So the vertex is basically what I highlighted over here, this point, and that's 0, 0. So that's the analysis part. And let's now move on to graph more functions. So the first function here I have is 3 times absolute value of x. You could kind of understand this as a vertical stretch by a factor of 3 on the parent function, or you could just plug in several points and plot this. So I have, if I plug in 0, it gives me 0, right? Because absolute value of 0 is 0 times 3 is still 0. If I plug in 1, it's going to give me 3. And if I plug in 2, it's going to give me 6. If I plug in 3, it's going to give me 9. So since we know the symmetric characteristic of absolute value functions, we know that we don't even do calculate. We know it's the points over here, right? And then we can connect them. over here. So let's do that. Okay. And then let's do that this side too. All right, so I probably should extend it a little bit, but that's okay. All right, so actually that makes it more ugly. Let's just ignore that part. Just put the arrow over here. And put the arrow over here. Okay, so that's how you graph. And sometimes your teacher may require you to plot 3 points, then you probably should extend the line a little bit. And then the next function here. Okay, let's draw the axis symmetry as well, so we can see something later. So my axis symmetry in this case is still over here. All right, so let's move on to the second graph. Let's use purple. So the second graph here says 2/3 times absolute value of x minus 2. In this case, my axis symmetry actually changed position because the x minus 2 here basically says I moved my graph to the right for 2 units. So if I move my whole graph, then that means my axis symmetry also moves. So I still need to change back to this. So my axis symmetry now is over here, right? So it's over here now. And then if I need to graph it, let's plot some points. So my first point is at 2. So if I plug in 2, I got 2 minus 2 is 0. 0 times 2, 2/3 is still 0. So it's over there. And then if I plug in, so let's plug in some number that can make the absolute value the multiple of 3. So that way we can easily calculate, we can get a whole number. So if I plug in 5, it's going to give me 3. 3 times 2/3 is 2. So 5 matches to 2 over here. And then I plug in 8. It's going to be 6. 6 times 2/3 is 4. So 8 gives me 4. And then if I plug in 10, 10 minus 2 is 8. Okay, that does not work. So I plug in 11. 11 minus 2 is 9. 9 times 2/3 gives me 6. So that's why I plug in 11. And then we know that since it's symmetric, we can plot the points here. So if that's -1, it's over here. If it's -4, if it's -4, it's going to give me 4. And then if it's -7, it's going to give me 6. So -7 matches to 6. And now I can draw the graph over here. Right, and then draw the graph over here. So that's for our second graph. And for the third one here, it says -1/2 times absolute value of x plus 5 plus 7. In this case, I know my axis symmetry shifted left for 5 units. So let's graph that part. I think I used this thickness. So let's use -5. Why is still this color? Okay, so -5 over here. All right, this graph is same length. So same length here. So, okay, now let's plot the points. Let's plot the points. So if I plug in -5, it's gonna give me 7 actually in this case, because I also shifted my graph up for 7 units. And then if I plug in, let's do some negative numbers for now. We can plug in -3. So if I plug in -3, the absolute value is going to give me 2. 2 times -1/2 is -1 plus 7 is 6. So -3 is going to give me 6. And then let's plug in -1. -1 plus 5 is 4. 4 times -1/2 is -2 plus 7 is 5. So plot over here. And then if I plug in 1, it's going to be 6, -3, and 4. So plugging 1 is going to be 4 over here. And then we can plot the other points. So plugging the other points. And then let's connect them. So let's connect them. Okay. So that's all my graphs here. And something to notice is that actually the right side, which is a not common color. So the right side of my graphs over here, the slope of it is actually the number in front of the absolute value. Let's look. So for the first graph here, my slope, it will be 3 for the right side of the graph, which in this case is this graph. So I have 3 over 1. So the slope is actually 3. For a second graph, it should be 2 over 3. Let's check. So 2 over 3, right? Changing y over changing x. So it is correct. And for the third graph, it's -1/2. So it does goes down. So it's negative. And then it's 1 over 2. So it's -1/2 or -1 over 2, the same thing, right? So that's for this. And let's do the last graph over here. So what is function? How about the function looks like this? If the function looks like this, we actually need to simplify it first. So we need to get out the slope like the other one. So let's do some modification to this function. So it becomes f of x equals, let's first move this 5 to the end, and let's deal with what's inside. So inside here, I basically need to take out -4/3. And then if I take out the -4/3, that means each term I need to multiply by -3/4. So the x just become the -4/3 x times -3/4, it becomes x. And 8 times -3/4, it's going to become -6. And then let's simplify this graph, this function too. If I take out this -4/3, since it's inside the absolute value, it's negative. When I take it out, it becomes positive because when it's negative, it just becomes positive when you take it out from the absolute value. So it becomes, but however, originally there's a negative sign here. So it's still -4/3, absolute value x minus 6 plus 5. So this is actually our function. And now let's just graph it on the graph we had above. So let me put this function here. Let's graph it. We know that axial symmetry now comes to, let's do that and then do it this color. So the axial symmetry now it's at x equal to 6 because over here it moves to the right for 6 units. And then I know now my vertex is gonna add 6, 5 because when I plug in 6, it's gonna give me 5. So that's 6, 5. So let's do that. 6, 5. So over here. And then if I know, since I already know the slope is gonna be -4/3 on the right side, I could plug in some points or I could just calculate it directly. If I just plug in some points, let's just see. So I plug in 9. 9 minus 6 is 3. 3 times -4/3 gives me -4 plus 5 is 1. So that gives me 1. Oh, oops. And then if I plug in, so I know that by symmetry here is over here. And then I could do another point, which I could do is 12. So I'm plugging 12. 12 minus 6 is 6. Times -4/3, that gives me -8 plus 5 is -3. So I got something over here, and I will also get it on this side, which gives me, let's see, it gives me -3 over here. And we can just connect the line over here and connect the line on this side. And you can see that my slope over here, it is -4/3 because the change in y is 1, 2, 3, 4, and changing x is 3. And since it goes down, it's a negative slope. So I think that concludes our video today. And thank you so much for watching. And I hope you enjoyed it. And if you have any questions, just comment and I will be very glad to answer. Thank you.